Hello students, now we will learn about growth rate and different types of growth rates. Growth rate in general can be defined as something measurable value that has been increased. Growth rate is the value that can be applied to increased size or number at particular time period, or we'll write with relation to time. We can give a formula to express this growth rate as absolute change means exact change to previous value. This absolute change can be expressed as present count or value minus past value divided by previous value comes under past value. If you want to find the percentage of change of growth rate, just multiply this one with 100. Percentage of growth rate is equal to present, or we can also write this one as final value minus previous value minus initial value or past value divided by initial value. Since we are talking about percentage, we will multiply with 100. This growth rate, it increases according to time period. Growth rate is of two types. One is arithmetic growth rate. Second one, geometric growth rate. These both types of growth rates are read in plants. First one, arithmetic growth rate. Arithmetic growth rate means during the growth of a plant body, one cell keeps on continuously dividing, other cells keeps on continuously differentiating into other or special types of cells. One cell continuously divide and increases length of so we can show that one in a diagrammatic representation like this is one cell. If it has undergone mitotic division, then it gives two cells. This one cell continuously keeps on dividing, but this will undergo differentiation. Again, this cell continuously again undergoes mitotic division. So we get we get again two number of new cells. This is new cell, this is new cell. But this one already got differentiated. In the next stage, one cell again it will undergo mitotic division and gives rise to two number of new cells. But this one in the next stage, this cell in the next stage, it undergoes differentiation. And this one is common. Already got differentiated after one mitotic division. So in such a way, cells keep on increasing their length or elongation. So by this arithmetic growth rate, cell length increases. By this arithmetic growth rate, plant length increases. Next, because one cell kept on continuously dividing and increasing in number. This is expressed with the formula length at particular final time period, that is equal to initial length plus growth rate at particular time period. Here LT indicates total length that is attained after a particular time period. Total length after a time. L0 or L0, it indicates length of initial size of the plant. So we'll write initial length of plant or germinating plant at initial time period, at a time period. R indicates rate of growth. Next, here T indicates time taken to reach total length of the plant. This arithmetic growth rate can also be expressed in terms of graph. This is x-axis, this is y-axis. Here we are considering on y-axis the height, on x-axis we are considering the time period. No cell will be having initial zero length, so it will be having some certain length. So if you take, I am not drawing the graph from the zero time period. So the graph will be linear graph, because we are talking about only continuous division of the cell. On some books you might have written the germinating seed is showing the elongated stem like this. So this indicates arithmetic growth rate. In case of germinating seed. So here graph is linear. In this linear graph is obtained because of what type of cells in a plant body? Means that is due to meristematic cells. So we can write arithmetic growth rate due to meristematic cells. Since we are seeing about mitotic division, every time two number of new cells are obtained. So arithmetic growth rate is also expressed as 2 plus 2 plus 2, because always new cells are being increased and the other cells are getting differentiated. Why this graph is linear? That is because of increase of number of cells always by mitosis. So this arithmetic growth rate is also expressed as increased number of, means two new baby cells, always they are increasing their constant number at one particular time period.